Okay, AA6DD, K6YYL. What would you like to talk about?
Well, let's describe our communications channel there, Kim, K6YYL, AA6DD. We're communicating direct wave propagation on 6 meters on a frequency of 50.300 megahertz. Basically 100 watts on each end of the transmission line, transmission distance. You're using a 5/8 or a 5/8 at about 22 feet up to the base of it. I'm using a 4-element beam that's not really quite pointed at you. It's about 45 feet up off the ground. And we're full quieting on both ends of the QSO. Indeed, for the 35-mile range here on 6 meters, that's fairly typical. That we get full quieting, which is really, really reliable. That is, you and I can talk here, whereas 40 meters we normally can't talk. The ground wave on 40 doesn't connect us unless we had some sort of big, huge monster vertical antennas running a kilowatt. Then we could, but but the 6 meters is much more convenient, and it's simplex, so we can talk as long as you want and not be timed out or anything of that nature. So it's a neat mode on a neat band here on 6 meters that we get to chit-chat on to each other and correlate what we hear on other bands. I did, speaking of that, I heard you check into the 40 meter emergency net. That is, I heard them respond to you, but just as I said, 35 miles is only feasible between you and I on 40 when we have a nice vertical index signal that goes straight up and straight down. But the band on 40 was quite long today, and I couldn't hear you at all when you checked in. K6YYL, AA6DD.
AA6DD, K6YYL, yes, and FM has a really nice sound to it here, of course. And then as far as, my 40 meter check-in today, as you probably remember, the dipole, the 40 meter dipole is not usable for transmit right now, so we need to get up there and fix that. And then so you heard me, you heard, well, you knew I had checked in because I had checked in on my 5/8 over 5/8 vertical there, so which it works pretty well for 40 meters. It was I believe it was a perfect SWR, so I kind of get a kick out of it, and that I use it for that. And it's more long distance with that one, with the 5/8 over 5/8 for 40 meters. But I did hear a local. He actually lives in Montclair, which is a city east of me, just and he may be, I don't know, 4 miles away at the most, I'm guessing. And so I heard him really well. I'm not sure if he's on a vertical as well, but anyway, I heard him nicely. Go ahead, Will.
Okay, well, that would make sense. 4 miles, the ground wave is quite strong on 40 for that kind of a distance, so horizontal or vertical, you'd probably pick him up. Yeah, I had forgot about that you were using the vertical 5/8 or 5/8 on 40 with a big wire counterpoise down below it. I should have flipped over to some of my 40 meter verticals that are on the ground and just to check to see if I could hear any wee ground wave signal coming in. But I didn't. I didn't think of doing that at the time because I had forgot that you weren't on the dipole. But that makes the difference between the distances that we're communicating here and how well it works. But everybody else is checking into the net this morning, so 40 was pretty good for Central and Northern California and Arizona and Nevada coming through. Go ahead.
Right, and I was going to make a video of it. I did, but it was just so sparse between anybody else talking that I could hear, so I just decided just to delete it. So, but at least you heard that I had checked in, not that you heard me, but you did hear somebody respond to me. And yeah, that is one of the net controllers here. I think he's in San Jose. I think that's what he said. So that's north, of course. But no, that's fun to just check in there. And I heard them call AA6USA, but I don't know if he checked in, and I didn't hear them respond back to him, so I'm not sure about that. But no, that 5/8 over 5/8 is quite the workhorse, and I think some people are pretty, amazed at what all it does, and everywhere I tune it up for, I have really good luck, and right here, of course, it's a perfect match right now, of course, for the 6 meters, as you made it for 6 meters.
It's 50 ohms on 6, and just a voltage spike on the lower frequency like 40. But we had added those wire counterpoises at the base just to make it so that it could become possibly efficient as low as 40 meters, and it turned out to work out quite well. All righty. Well, that's how long of the video do you want? Go ahead.
Well, I was thinking about making it 10 minutes, so we have about 3 minutes and 50 seconds ish.
Okay. Very good. Well, I was working on the lab over here on some weird phenomenon that a transistor is doing that it shouldn't be doing, and trying to figure out why it's doing what it's doing, which is always a challenge when something like that is not exactly working the way the textbooks say it should. It's actually a relaxation oscillator. Have you ever seen, I don't know if you ever have, you know what the little NE2, NE, letters N and E, number 2 bulbs are? Do you know what those are?
I don't think so.
Okay, they're inert gas. They're just 2 pieces of metal inside of a glass bulb, and the inert gas is taken, and the air is taken out, and inert gas is put in there. It's the same thing as, have you seen these little bulbs that sort of flash around to act like that they're a flame, but they're not a flame? They're actually an electric bulb that's screwed into 110.
Yes, I actually have some of those.
Well, those are just big versions of NE2s. And if you took one of those and soldered it to a half-wavelength wire, all right, on any band, it could be 2 meters or 6 or whatever, but a half-wavelength long, and then transmitted RF into it. Not with a, well, you can actually transmit, but you can transmit into the dipole. It has to be a dipole, and it'll light up because it's high voltage on the ends, and it'll make them light. But even at receive, if you have one just on receive, if the transmitter is really close to it and pumping a lot of energy into a receive antenna, the bulb will also light up. And so historically they've been used to look at the high voltages on antennas like that. And then you can hook them across a capacitor and have a resistor feeding the capacitor. And what will happen is that the capacitor will take time to charge up, more time, because you're going through the resistor. And then eventually it'll get to a voltage of about 80, 90 volts. And the NE2 will then light. And when it lights, it will discharge the capacitor. It'll flash. And then it'll start all over again. The resistor will take time to charge up the capacitor, then the bulb will flash and go back down again. And depending on the value of the resistor and the value of the capacitor, because the NE2 is right across the capacitor, or any one like that, will be how fast it flashes. And so they were used for all sorts of stuff historically. You can even make code practice oscillators on them. If you made them flash 800 times a second, and then take the sound through a transformer to a speaker, you would hear a sawtooth kind of for a Morse code oscillator, and yet there was no tubes, there were no transistors, there was only resistor, capacitor, and the speaker making it do that. I don't know if that makes sense to you or not. Go ahead.
Yeah, I think so. Okay, we're closing in on the time. I'd like to probably end up here. Anything else here to say for this video?
No, that's all right. It's called a relaxation oscillator. Relaxation oscillator is what a circuit like that is called. So who knows? Maybe there's some on the YouTube that you can look up and see some. We'll say 73 is Kim, and we're going to lunch. K6YYL, AA6DD, listening out.
Okay, very good. Well, I'm going to post this video to YouTube probably. I'm going to check it first, make sure the sound quality is good enough. And if not, then we'll do it again. So, but thank you very much. And yeah, you can just check out my YouTube channel, my call sign, K6YYL. Do a search on that, and you can. It should be loaded. I'll have to load it, so it'll take, I don't know, 25 minutes to load after I check it. So I'm assuming you'll still be there at the library, correct?
Yes, Roger.
Okay. All right, we'll have a nice lunch and library time. AA6DD, K6YYL.
Okay. Have you had time to look up the two young ladies I gave you their calls and names?
Not yet. I will probably do that. Oh, I did actually. Yes, I did. Real quick, I did.
Oh, okay.
Okay, well, I will talk to you later. AA6DD, K6YYL.
All right, have a good day, Kim. We'll catch you later this evening, hopefully. K6YYL, AA6DD, once more clear.
All right, 7-3 will. K6YYL monitoring.